Hello children. Yesterday we have seen some very basic things. Now one another question we will discuss. Using the truth table, verify. So in that one question I will take P or Q and R is equivalent to P or Q and P or R. These are the distributive laws actually. We have to prove the equivalence. Equivalence means LHS should be equal to RHS. Now, how we can prove? By having the truth table. Construct the truth table and verify. How to verify? So first of all, how many rows I want, that I have to select. In that all these should come. Switches are 3. P, Q, R. Means each switch has 2 positions. 2. How many switches? 3. Means 2 raised to 3 is equal to 8. Means the rows would be 8. Columns, how many columns would be there? We are less bother of it. That will come automatically. So switches names I will write P, Q, R. These are the 3 switches. And whatever is needed, that will go on. Now this is 2 raised to 3. I will write here 2 raised to 3 is equal to 8. For what? These are the number of the sample points. So out of that, half of this will be true values for this and half will be false values of this. Half of 8 is 4. So 4 times I will write T, 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 T. Half times I will write false, false. Means 4 times I will write false, 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 false. This way, one switch is over. Then the remaining switches, that will be automatically coming. Half of this for this. Means totally 4 values for the first. Then half number of the values for this. Means 2 times T, 2 times false. 2 times T, 2 times false. For the last switch, half of this. Means 1 time true, 1 times false. T, F, T, F, T, F, T, F. Once this part is over, that means much of the things we have achieved. Now what I want, P and Q or R. So first of all, I will take this Q and R. This I will get. Then what I will do? I will do this total. P or Q and R. The remaining things we will see afterwards. Now this Q and R. Q and R. This is Q and R. And means what? And means the series circuit. Series circuit will be like this. This is Q and this is R switch. The current will be sent from this side and has to go on the other side. In the first case, this is true, this is true. True means this switch is on, this switch is also on, and the current will come, that means it will be true. Now in this case, the first switch is on and the second switch is off. First is true, second is false, means this is on, this is off. So current will come up to this, but after that it will not go, that means it is false. For this also it will be false. For this, false. Now the both are on, so this is true. False. False. And false. Now this column is over. Now P or Q and R. Now this I will make the circuit for that. Or means the parallel circuit. Here I have the place. Or means the parallel circuit. So I will make like this. P or this is P, Q and R. Q and R. By combining these two switches, Q and R, this is a combination, and from that I got one switch. Current will be sent from this side and we will check whether we can get the shock or not. Now P or this is Q and R. With this, this will be in OR. OR means parallel. Both are true, this will be true. Now in this P switch is on and this switch is off. So current will go from this side. This is on means from this side it will go. That means it has one branch to go. So current will go, that means it is true. For this also it will be true. For this also it will be true. For this, now this is off and this is on. So from lower side it will go. That means this is also true. For this, both are open. So this is false. For this also both are open. That means this is false. And for this also both are open. So it is false. Numbers we will give 1, 2, 3, 4, 5. Now we will proceed further. Now this part is over. Now this part. Now I will find P or Q. P or Q. I will make the circuit P and here or means parallel, here it should be Q. So I have to see the switch P and switch Q. P switch, Q switch. They are in or means parallel, both are true, so this is also true. In this, both are true, this is also true. Now in this, one is true, one is false. This is true, this is false. So current will go from the upper side. True. This is also same case. True. This is also same case. From the lower side the current will go. True. This is also true. This is both are open. False. Both are open, false. Okay. Now I want this and then I will club this together. P or R. This was fifth, this is sixth column, this is seventh column, and the last column we will give the number afterwards. Okay. P or R. Now the switch is changing. These two are in OR, so R. These two are in OR, parallel, both are true, true. One is true, then also true. Both are true, true. One is true, one is false, then also true. One false, other true, true. Both are false, false. One true, one false, true. Both are false, false. Now for the last column, eighth column, these two I want together. So P or Q and P or R. This is the eighth column. Where are these two? P and Q, P or Q is this, P or R is this, and I have to make AND circuit. AND circuit means a series circuit. So only for the explanation purpose I am drawing the circuit. Otherwise, after you are habitual to this, definitely you will solve without drawing the circuit. But it is better. Some rough work you have to do. Which are these? P or Q. This is P or Q. This is one sided switch. Then P or R. P or R. And they are joined in series. Try to pass the current from this side and see whether this is coming. Now these are the two. Both are in and means in the series. Both are true. Current will pass. True. This is also true. This is also true. This is also true. This is also true. One is true, one is false. In the series, current will not go. So this is false. This is also false. This is also false. Okay. What was the question? Prove the equivalence. That means the LHS and RHS values should be same. This LHS we have completed over here. P or this. And this LHS, the last is this. Now see the column number 5th and column number 8. Check whether all the entries are same. Up to this, correct. After this, also correct. So all the entries in column number 5 and column number 8 are identical. So we have to write the statement. All the entries in column number 5 and column number 8 are identical. Identical means same. Therefore, P or Q and R is equivalent to P or Q and P or R. Therefore, this is proved. So, this way you have to complete this question. I am taking the selective questions. Now these very basic steps will clear one big question, and that is draw the circuit, or from the circuit write the logical equivalent statement, or vice versa. These questions are coming, so that also we have to see, and then this lesson will be over. Very simple topics will be there, that is duality, negation. When you read in the textbook, there also you will understand. It is not a very difficult thing. There is one question. Express the following circuit in symbolic form of logic. Express the following circuit today's date I forgot to write, 22/4/2020. Express the following circuit in symbolic form of logic. Symbolic form of logic. So some simple question first we will take. The circuit is given like this. This is minus and this is plus. This way the circuit is. What is in this? This is one switch S1, and to this is a parallel branch, and this parallel branch there are two switches connected in series. That only we have to state. But before that, what is this S1, S2, S3, that we have to write. So P, what it denotes? The switch S1. Only you can write the switch S1, or you will write the switch S1 is closed. Closed means this is on. Q. Second switch. The switch S2 is closed. Then the R. What is this? The switch S3 is closed. On that lamp we will write small letter L. The lamp glows. All these are the conditions. If this is closed, this is closed, this is closed, and the lamp will glow, will or will not, that is another thing. Okay. Now, aim of this circuit is to glow the lamp. This is the aim. what we will do in this, how this switches, now the logical form of the circuit is, or symbolic form will be, symbolic form of logic is, symbolic form of logic is, what is the symbolic form? The first switch P, this is P. It is connected in parallel with the series combination of these two. So I will put a bracket. This will be Q. This is in series and that is R. If it is connected like this, what will happen? It is equivalent to the lamp L will glow. So this way we have to complete. And then this question is over. Now we will take some other question. Where the combinations are somewhat different. This was the first. Now I will take the second one. We will take somewhat complicated circuit. S1, S2, it has a parallel branch. Then this is S1 dash. Then again it is broken like this. This is S2 dash. Then again this will be S1. Then S3. And then this is close. And this branch I will just redraw it. Will get connected to this. And now the supply is given. And this is L. So S2 dash, S1, S3. Write this properly. This is S2 dash. S2 dash. This. So what we can do in this is, first of all, I have to write all this. 3 switches are there, so up to R I have to go. Now this last remark, lamp L glows, that I will take afterwards. But what is that dash? There are 2 dashes. Dash means the opposite of it. So S1 is P. So is the dash is negation P. The switch the same way. S1 dash is closed. That means S1 dash is closed means this is open. The opposite idea. Then S2 dash is also there. So negation Q means which is closed, S2 dash is closed. Or switch S2 is open. That way it will come. But don't make too much confusion. Go on writing the same thing. And then now I will write L. The lamp grows. This way. Now the symbolic form of logic is form of logic is. What is the symbolic form? These two are in a single branch. This is the first branch. So I will put one bracket to it. This is the bracket to it. S1 means P. It is AND. S2 means Q. P and Q. This first branch is over. Now for that, this is a parallel branch. So OR. In this OR, who is first? This. S1 dash. S1 dash means negation of P. This is the parallel branch. I am writing in the bracket negation of P. For this much is in series. This whole and this, they are parallel to each other. But for this branch is in series, means joined in the front. S1 dash, in front of it, this parallel combination comes, means negation P. Then this is, here it is in front, so AND. In that AND, what it is? These are parallel. S2 dash means negation Q or P or R. This is the parallel combination. This will be the logical statement. And if this is like this, the lamp should glow equivalent to L. This way you can frame the circuits, and from the circuits from the circuit we have formed the logical statement. From the logical statement go exactly inverse and form the circuit. Now this question may extend to find the truth table also. So truth table, how to draw, we have prepared it. So accordingly make the truth table of this also. Hope you have understood the lesson. From this very basic idea, try to develop your fundamentals. So okay, we will see what to take in the next video. Till then, goodbye.